Okay, so first of all, I'm going to show you the short, not so great way because you're probably going to be asked to do this by hand, but I want you to know how to do this on your calculator as well. So here it says, find the zeros of this function. Zeros, sometimes, or the x-intercepts, excuse me, sometimes we have other words for just x-intercepts. So sometimes they're called zeros, sometimes they're called solutions, sometimes they're called roots, and in this case they're using the word or the phrase x-intercepts. So if you see any of those phrases as a general idea, they're talking about where does this thing cross the x-axis. When that happens, if you're ever going to use your calculator, you always do the following. You set it equal to 0, because it's where the y value is 0. That's what an intercept is, for x-intercept that is. And then you just take this stuff over here, and you put it into y1. You take this stuff over here, and you put it into y2. And then you go second trace, 5, enter, enter, arrow, enter. So now if I look at that on my calculator, you don't have to do this, I just want to show you, because we've done this in our class before. So let's say I'm going to find one of them. I go into my y equals. Hello? Hello? Are you kidding me? Alright, maybe I'll do that later. Whatever. Let's do it by algebraic means first then, I guess. Great. So as I look at x cubed minus x squared minus x plus 1 equal to 0, I notice that there are a couple of things going on. I see there are 4 terms. Whenever you see 4 terms, it's a good guess in this course, and probably in any other math course, that you're doing factoring by grouping. And I think we've done this before in our P chapter. If you're doing factoring by grouping, I look at the first 2 things that have the 2 highest powers, and I go, hey, what goes into both of those things?
X squared.
X squared goes into it. So then I write down what's left over, which would be an x and a minus 1, because x squared times x is x cubed, and x squared times minus 1 is minus x squared. Now, if you're doing this right, then the second parentheses that you make has to look exactly like the first one. You don't have a choice. Otherwise, you cannot do factoring by grouping. So I automatically know I'm writing down another one of those parentheses. And then I look at the last 2 things there, the minus x and the plus 1, and I'm like, okay, well, I need to make that into this stuff here, so what did I have to factor out? Negative 1. And then we talked about earlier in our class that these 2 things are the same, this x minus 1 thing and this x minus 1 thing. So what I'm going to do is I'm going to represent them, and I talked about why this is before. If you don't remember, go back and look at your notes, as 1 parentheses. And then whatever is left over, I put in the other parentheses, so that x squared minus 1 goes in the second parentheses. And don't forget, this is all, of course, still equal to 0. So in case you're having difficulty following along, this thing and this thing are now here, because we factored out the x minus 1, and left over was the x squared and the minus 1, and that's why I went in this parentheses. So that's what happened. Now I look into that second parentheses and I notice, I can factor that. So I keep going. I have x minus 1, and then I have x plus 1, x minus 1, and it's still equal to 0. And if I solve this, that means that, of course, because of the 0 product property, that any one of these parentheses could be 0 and produce the 0 that comes out on the right-hand side. And so I look inside each of those parentheses and I ask myself, what makes these parentheses 0? And the answer is that in the first one, it's x equals 1. And in the second one, it's x equals negative 1. And in the third one, it's x equals 1 again. So the crazy thing is there are 3 zeros. In fact, I knew there were going to be 3 zeros. How did I know there were going to be 3? Because it's cubed. So that's how you know there's going to be 3. And the kind of weird thing is 2 of them are the same. They call that a double root. A double root. And here's the awesome thing about knowing what's going on in mathematics. Like, I don't need a calculator. Watch this. I know that 2 of these roots, -1 and 1. I know that this graph has to go through that point and through that point. I know that for a fact. Has to touch it somehow. Because it says, those are my roots, my x-intercepts. And did you notice that in this graph, when they gave it to me, that it was x cubed? What does that look like? An S goes up to the right, down to the left, yes?
Yeah.
So I know it looks like this. Because it has to touch those points and looks like that. Okay, I'm going to give you 60 seconds. Finish the graph and then compare with the neighbor. You know it has to look like an S.
Oh. Shoot. Be quiet. God.
Oh, no.
How many people had the graph that looks like this where there's a valley sitting at this point? Raise your hands high. This is the only possible solution. Notice that that place where the valley was had a double root. 1 and 1 again. You see that? If you ever see a double root, there will be a mountain or a valley there. I don't know which one, depends on the graph. But if you ever see a double root, mountain or valley, I think I'm going to write that down. Double root is a mountain or valley. Weird. Mountains and valleys in math. Let's try another one. I don't know. It's psychic ability, I guess. Let's try again. Here we go. I'm looking for the zeros. X cubed minus 2x squared equals 0. I said it equal to 0. Factor. It's an F word. X squared times x minus 2 equals 0. What are my solutions? My x-intercepts, my zeros, my roots? 2.
Or 0.
Or 0. Or here, maybe this is not clear.
Or 0.
Yes. Good job.
Yeah, or 0.
So, thank you, Joe. X equals 0. X equals 0. X equals 2. This means I have 3 roots. How do I know there are going to be 3 roots? Cubed. 3 of them. Oh, look, 2 are the same. One's at 0. And one's at 2. These are my 2 x-intercepts. Remember, those are the only places you can touch the x-axis. That's it. No other choices. Oh, it's x cubed. I know that means up to the right, down to the left. I'm going to pause now. You're going to finish off the graph. When you're done finishing off the graph, compare with 2 people. Okay, hearing all the conversation, that must mean that everybody's ready. Oh, wow.
Okay, so how do we do that?
See how I messed up again.
Look at his face.
No.
The double root means there's a mountain or valley there. So that means at 0 there had to be a mountain or a valley. The only way you can make it happen is with a mountain, not a valley. What's a valley? Okay, so the question is, what's a valley?
No, I said
So we're going to do a... No, that's not the question.
You said that's a valley. You didn't ask anything.
Oh, you said that's a valley? Oh, okay. Alright, sorry, questions? Okay, the next one, we're working backwards. Olivia,
Yes.
it tells me that there are the zeros 2, 3, and -1. What do you think the power is?
Oh, okay. 3.
Why?
I just guessed.
Why?
Just because the 3 was in the middle.
Good guess. How come you didn't pick 2? Because it wasn't in the middle?
Yeah.
Okay, I like it. At least there was some reasoning behind that. The answer is right, the reason is crap. But at least there was a reason, and I do like that about it. I like that.
Because there's 3 zeros.
There are 3 zeros. So the answer is 3 because there are 3 things. If there are 3 zeros, the power is 3. When I get done with this thing, I should see something with a power of 3. So you start backwards. Or in other words, if you know that these are the zeros, write that down. I know that means my x is 2. I know that means my x is also 3. And I also know that my x is -1. Now, if you're working backwards, if you remember how this works, the step that happened right before that was when the number was not on the other side from the x. It was with the x, because they were friends. Until somebody took that person's makeup brush, and then they kicked them over to the other side. Like somebody's going to watch this 3 years from now and have no idea what I'm talking about.
I don't.
If I move the 2 over to the other side with the x so they can be friendly again, I would have x minus 2 equals 0. Oh, no, that's a 0. Then, if I did the middle one and move the 3 over, that would be x minus 3 equals 0. See, there's no, oh, it's a 0. And if I move the 1 over, which was negative, it now becomes positive, so x plus 1 is 0. Right before this step, working backwards, you might remember that was where we had the 3 parentheses times each other equal to 0. Do you guys remember that? Or in other words, x minus 2 times x minus 3 times x plus 1 equals 0. That's why we went to this thing. Either that parentheses was equal to 0, that parentheses was equal to 0, that one was equal to 0. And then we moved stuff over and solved it, and that's how we got the red, which were the 3 zeros. And now comes the fun part. Now is where we multiply it all out.
Oil sounds oil.
FOIL. Now you might, I'm going to pause now because this is